One of the most common uses of quadratics in real life is modeling the motion of a thrown object. So expect to see lots of word problems about throwing baseballs and hitting baseballs and throwing footballs and soccer balls and dropping objects and things like that. All right, guys, lesson 5.3 is titled Factoring. In this lesson, we're going to teach you how to factor a polynomial. So in the last two lessons, 5.1 and 5.2, we've talked about how to graph a quadratic that's in factored or intercept form and how to solve them if they're in factored or intercept form. But what if the equation is given to you in a different form? What if it's already got the x squared and it doesn't have those nice pretty factors that you can just set equal to 0? Well, in this lesson, we're going to show you how to put it into factored form so that you can use your skills from 5.1 and 5.2 on almost any quadratics. All right, so what we mean by factors in math, you may remember this from elementary school, is that the factors are the pieces of an expression that are getting multiplied together. So 4 times x squared times y, the factors there are 4, the x squared, which really is x times x, and the y. In an expression like this, which would be quadratic, your factors are x minus 2 and x plus 3. So those two pieces are your factors. Factoring is the process of breaking down algebraic expressions into the most simplified form of all its factors. To factor a quadratic expression means you're going to write it as the product of your linear expressions. You're breaking it down as far as it can go. There's lots of different strategies, but the first thing you're always going to want to do is look for a GCF, or a greatest common factor, and factor that out before going forward with any other strategies. So since that's the first thing I want you to practice doing, that's the first thing I'm going to teach you to do. So if I have this example, 6x squared plus 2x, the first thing I want you to do is find the GCF of all the terms. So when I look at this, each of these is divisible by 2. Also, each of them has an x. If you can't see what the GCF is, you can always do your factor trees. So you've got 6 and you've got x squared, you've got 2 and x. Over here, I've got 2 and 3, and then x and x. So both of them have a 2, and both of them have an x. You may have been able to see that without doing that factor tree, and that's okay. If you can figure out what the greatest common factor is, go ahead and pull that out front. So then you are going to write down your GCF out front, then an open set of parentheses. To figure out what goes in the parentheses, you're simply going to divide each term by the GCF. So basically what we're doing is the opposite of the distribution property. Instead of distributing this 2x in, we're figuring out what's been distributed in, and then we're pulling it back out. So I'm going to put my 2x here, and I'm going to divide 6x squared by 2x. Well, what's left when I divide that by 2x is 3x. If you look at your factor tree, it's the things that it didn't have in common. There's still a 3x left behind. When I divide 2x by 2x, I'm left with just 1. There's nothing left behind over here, so I've still just got that 1. So the factored form of this expression is 2x times 3x plus 1. So if I were going to solve this, I would then set 2x equal to 0, and I would set 3x plus 1 equal to 0. All right, let's go ahead and do another example. All right, so we've already talked about the steps for solving a quadratic using equations, but this is the extended edition. This is when you actually have to factor it, and it's not already given to you in factored form. So the first thing you're going to do is make sure that your equation is set equal to 0. So this is going to be 3x squared minus 27x equals 0. If you've got a y or an f of x or anything like that over here, you're just going to take that out and set it equal to 0. You want to know what is the value of the x when y is 0, because ultimately we're looking for our x-intercepts. We're looking for those zeros. So then the next thing you're going to do is check to see if there is a GCF that can be factored out. So both of these terms are divisible by 3. They also both have an x. So I'm going to factor out a 3x. When I divide 3x squared by 3x, the 3's cancel. X squared divided by x is just x. So what's left behind in this term is x. When I divide negative 27x by 3x, the x's cancel. Negative 27 divided by 3 is negative 9. So This is my new equation. Now the next step is going to be to factor. If there's more factoring to be done, sometimes, and we're going to get to examples like this later on, sometimes even after you've factored out the GCF, there's more factoring to be done, and I'll show you how to do that in later videos. Now you're ready to set each factor equal to 0. So this is what we did back in the previous lesson. You're going to say 3x equals 0 and x minus 9 equals 0. When I divide by 3 here, I get x equals 0, and when I add 9 here, I get x equals 9. So my two factors, or my two zeros, or x-intercepts, are x equals 0 and x equals 9. So that last step was to solve each equation. All right, you guys are ready to go on to your next page, I believe, and start your U-tries. Yep, you guys, I want you to tell me what are the factors of this, and then I want you to actually factor and solve these equations. All right, and I will see you in video 2.